see when people start arriving.
I'm going to guess in about 10 seconds.
You think so?
Yes, ma'am.
You're always first since you're remote. You're always first. You're just on top of the ball, Shreyas. Okay, let's see. Here they go. You were so right. You said 10 seconds, and here they come. Right, I see Jack. Andrew is here. Ava's here. Sarah's here. Ella's here. Amelia, Jonathan, Hannah, Lane, Mia. Okay, go ahead and get your 2.4B notes out. We are going to have a whirlwind with Piecewise Functions today. Whirlwind lesson, 30 minutes. We can do it. We'll also have some time tomorrow to continue working on this, but we're going to get a jump start on it today. Okay, I see Nash is here. Daphne is here. Still waiting on Augustine. Josh is here. Miles is here. Let's see, is Catherine here? Not yet. We're still waiting on Catherine. Ethan is here. So we're just waiting. There she is. Get your 2.4B notes out. We're going to get started on those today. And we will have time in our next class to continue to work on this. So we're waiting on Augustine. And that's it. That's it. Everybody else is here. That's fantastic. Okay. He still has 2 more minutes, so we'll just give him some time to get situated. Now, remember that you have a test next week. You have a test next Tuesday. So we need to make sure that we are becoming one with all of the material so that we can all do exceptionally well on that test on Tuesday. We will be meeting in the library to take the test if you're on campus. If not, there will be access on Canvas to open up the test there. It will be remotely proctored. And then, of course, whether you're here or remote, you are going to be uploading your single PDF in Canvas for me to grade there, but you will be turning it in physically as well. So hopefully you've been working all the practice problems in the packet. The solutions are posted in the Unit 3 module on Canvas. So if you want to check as you're working on, because it's been a while since we did linear inequalities, solving linear inequalities and graphing. Make sure that you are doing all of those practice problems if you feel the need to become better acquainted with all of that material. Remember, the more that you do, the better that you're familiar with the problem, so you don't choke or have a forgetfulness on the test. It'll be right there fresh in your mind. So do make sure that you're doing any and all of the practice material. There is a 2.4B My Math Lab that will be due next week as well. But make sure that you're starting to work on that because we'll be familiar with that material after today. Okay, I'm going to submit my attendance and we're going to do 30 minutes of Piecewise Functions. How exciting. So let me make sure we're doing.
Dr. P, I saw you We're recording it, but do you want me to record it too or no?
Just in case something goes wrong on my end, if you don't mind, that would be fantastic. That would be awesome. Thank you, Josh. I appreciate it greatly. So here we go. Piecewise functions. Okay, so piecewise functions. What is a piecewise function? A piecewise function, also known as a conditional function, that's another name for it. A piecewise function is a function that is defined by different rules, different equations on different parts of the domain in different intervals. So depending on what your input value is on the piecewise function, you're going to use a specific part of the rule. So can anybody think of a piecewise function that we have worked with by chance? Maybe the absolute value function? If we think back to the definition of the absolute value parent function, remember that we had y equals the absolute value of x, but we said that the absolute value of x could be represented given two cases. In the instance that the input to the absolute value function.
Dr. P, we can't see what you're writing.
You can't see it? I'm sharing my screen. You can't see it? Okay, let's try again.
I could see.
You can see it? Well,
I can see.
I can see it.
can you
I
see
can't.
I can't.
Cannot. Oh, that's terrible. Let's try this again. I'm gonna stop and then I'm gonna start and tell me piecewise functions. Here we go. Slowly but surely. There, you see it now?
There it is.
Okay, piecewise functions, piecewise functions. So we're reminding ourselves of the definition of the absolute value function. Remember, if the input to the absolute value function was positive or zero, so remember, it can be a number, but it could also be an expression. If that is positive or zero, what did we do? We kept it as is. However, if the input of the function was negative, what did we do to that input? Do we remember? Nobody?
Absolute value.
Well, what did we do to the input if it was a negative value? We
We made it positive. Okay.
Well, in essence, since it does represent distance, it does become positive if it's negative. But how did we do that? We took the opposite. We negated that input, right? So we wrote this absolute value parent function as a piecewise function. We had two different rules depending on what our input was. So if I were to graph this using the rule, you should notice that you have two intervals for which this is defined. We have it defined for x equaling 0 and being greater than 0. So if I were to represent that interval using interval notation, it would be closed 0 to positive infinity. And in the instance that our input was 0 or positive, I used y equal x. So if x was in the interval closed to infinity, I used the rule f of x equals x. And we should know how to graph that. That's just a line with a slope of 1 and a y-intercept of 0, 0. Fair? This is just y equals x. Now, if the input was negative, so if x was an element of the set, how would I write that as an interval? All x is less than 0. How would I write that using interval notation?
Parentheses 0, or parentheses negative infinity 0 parentheses.
Very good. So if x was in this interval, then I would use the purple part of the rule. right? The second case. X, well, again, it wouldn't include that because we didn't define it there, but it would be a line with a slope of -1 and y-intercept of 0, 0 if I include it, but it's not included in that interval. So this would be y equals -x. So technically, I have two components, two rules that would allow me to graph the parent absolute value function. Does that make sense? So technically, the absolute value function can be represented as a piecewise function. Okay, let's try another example. Let's try, I'm going to give you a piecewise function. So let me say f of x equals, let me give you this piecewise function here. What if I give you x plus 1 if x is greater than or equal to 2, and -x minus 1 if x is less than 2. So I have a piecewise function. I have two different intervals to represent this piecewise rule for each interval. So if I'm looking at this interval here, if I'm given an x value that is greater than or equal to 2, that means I'm starting at x equal 2 and I'm looking at this interval here. And how would I represent that in interval notation? X is greater than or equal to 2.
Brackets 2. Infinity. Parentheses.
Beautiful. Okay. So if I'm there, I'm following this rule. Okay. So how would I graph f of x equals x plus 1? How, that's just a line. That's just a linear equation. How would I graph that? How would I begin to graph that line?
A closed circle at 2, 3.
Okay, how did you get that?
I substituted 2 into the equation.
Okay, so if I let x equal 2, because that's where it starts being defined. That's the first x value for which it's defined. So if I let x equal 2, then I'm going to get 2 plus 1, which is equal to 3. So when I evaluate the function at x equal 2, I have 3. So I can represent that as a point 2, 3. So at 2, 3, I'm defined. Now from there, how do I continue to graph this piece of the function? What do I know about this rule?
The slope's 1.
Beautiful. So from this point, I would rise. How much?
1.
And run.
1.
Beautiful. And there's that piece. Now so this is y equals x plus 1 defined on that interval. Now the second part is defined for all x's less than 2. So that means I'm looking at this interval. And how would I represent that in interval notation? Anybody? How would I represent this using interval notation?
Parentheses,
Open parentheses. Oh, you
negative
can go.
infinity, 2, close parentheses,
Closed. Do I see an or equal to in that inequality?
like close parentheses.
Oh, just closed. Okay, so open parentheses.
Yep.
Yeah, I understand what you're saying. Thank you, Mia. I appreciate it. Okay, so when I have an input value that is less than 2, I'm going to use this rule. So we can do the same thing that we did before and say, okay, well, what would it be if I were at x equal 2? We know it's not included, but if I were to put in 2, what would I get for my output?
Negative 3.
Beautiful. So at 2, I'm at -3 on this part, but I'm not included, so I have an open circle. I'm not including that point because it's only for x's less than 2, but that tells me where to go on my graph. Now, what is the slope of that line?
-1.
Okay, so from here, I can go up 1 and to the left 1, right? And I could get this part of the graph. This part of the piecewise function. So again, the first thing I like to do is define my intervals. I like to define my intervals so I know what different areas I'm graphing the two, in this case, two different components. So given an equation, a piecewise function, two rules in this case, if I were to give you an input, you should be able to determine which rule you're going to use. So if I asked you for kicks to evaluate f at 5, which one would you use? The first case, the green, or the second case, the purple?
Green.
I would use the green, absolutely, because x equal 5 would fall into that interval. So I would just substitute it in. I'd get my output and I could write it as a point. And so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There I am. So you should be able to determine an output given a specific input and be able to know which rule to use. Any questions on that? Okay, so given a piecewise function, you should be able to graph it and maybe evaluate some input values.
I have a question.
Yes, ma'am.
On the range of this function, how would we write that?
Okay, so first of all, since you mentioned it, what would the domain of this piecewise function be? And we have to take all components of the graph. This graph consists of all these pieces. So what would
Negative infinity to infinity?
Beautiful, okay? Because every x value is defined. Now, the range, if I'm reading the graph, the smallest y value that is defined. How would I write this as an interval? The range. Does anybody?
-3?
-3. Well, what about
Or like, oh, sorry.
Go ahead. No, keep going. Keep going. So the lowest value that I see is -2, but is it included?
No.
So how would I represent that as an interval notation?
An open parentheses.
Yeah, so that's saying I'm going to -2, but I'm not including it because it's an open circle. And then what is the largest y value that this takes on?
Infinity.
Positive infinity. Beautiful. So does everybody see that? That was an excellent thing to point.
Isn't that point at -3?
Is it -3? You are absolutely correct. I don't know why I wrote -2. You are absolutely correct. 1, 2, 3. Yes, ma'am. So -3. Yes. Yes, yes, yes. Does everybody see that? Yes.
Yes.
Okay. All right. Let's move on. I want to do this first one on this page, and then we'll probably have to stop. If I wanted to write the equation for the piecewise function that is represented by this graph, does anybody have a clue? Well, the first thing I would do is I would define my intervals, my different pieces. So can anybody tell me one interval that we might want to pay attention to? What's the first interval?
Open parentheses, comma, 2, closed bracket.
Say that again. Open parentheses.
Comma, 2,
Well, what's the
closed
first
bracket.
What's the first value in the open parentheses?
Oh, sorry,
Negative infinity to 2, and then you said close to. I like it. So that's defining this piece right here. I like it. And then another piece we have. What's our other piece?
the other
Open
piece.
to
Open to
infinity open.
infinity open. I like it. Okay, so now when I go to write the piecewise function, I see it's defined on 2 intervals. Okay, so the first interval, the green one, if I were to represent that as an inequality, how would I represent negative infinity to close to as an inequality. X would be
Less than or equal to 2.
less than or equal to 2. That is magnificent. And what would be the rule, the equation that corresponds to this? F of x equals what? What, do you recognize that? Does anybody recognize what?
The absolute value of x.
Yeah, it sure is. It sure is. And I could take that one step further and expand on a little bit more. Okay, what about the second interval? How would I represent that as an inequality? X.
X is greater than 2.
Beautiful. And how would I represent that rule? F of x equals what? How am I going to represent?
3.
Beautiful, because it is a horizontal line at y equal 3. Magnificent. So that's how I would write the rule, the piecewise rules, the piecewise function that's represented by this graph. Now, guess what? We can go to Desmos and we can check anything that we do in Desmos. In our calculators, we have to have it as y equals. In Desmos, we do not. So let's go ahead and see how we would graph a piecewise function using Desmos. So piecewise function using Desmos. So I'm going to go ahead and input that first equation, that first example that we did. And the first example that we did was, can we read it? Can somebody read me that one we wrote right underneath the first one? Y equals what? Anybody? Somebody read me the equations. Nobody wants to read me the equations? We're looking at the example. The one we did after we talked about the absolute value function. We had f of x equals what? X plus 1, right? When x is greater than or equal to 2. So how am I going to use Desmos? Well, I have to write separate equations for each part. So I'm going to have y equals the open brace, and I have to define the domain values for which the interval for which this part of the rule is true. So I'm going to say x greater than or equal to 2, colon, x plus 1. That's that piece. So we graph this by hand, okay? Now, the second part of that rule was y of the piecewise function. The second rule was y equal, and it was defined on all x's that were less than 2. And the rule that corresponded to that interval, those input values, was negative x minus 1. So this is what we just graphed by hand. Does everybody see this? Now, it's not going to show you what's happening here. It's going to give you graphs, but you have to know that this point is included for this one, but not for this one. Does that make sense? But isn't this beautiful how you can graph piecewise functions in Desmos? I love it. It's magnificent. You can check all of your work. Now, if you notice, on our packet, and let me go back to here and share this screen now. So if I were to go back to my packet, we just graphed this one. So let me quit here. Okay, we just graphed this in Desmos. So that's magnificent that we can do this. Again, in Desmos, you first define the interval and then the rule that corresponds to it. You first define the interval and then you define the rule that corresponds to it. Okay, being very careful with your endpoints. Okay, now we did number 1, but notice you have a lot of practice problems here. So I think it's in your best interest to maybe start working on these practice problems because in Friday's class, no, tomorrow's class, because today's Wednesday, in tomorrow's class, we are going to be discussing any questions on any of these problems. So I gave you a lot of practice. So do you have to do it all? No. Is it due for a grade? No. But you should be intrinsically motivated to work through these problems and do as many as you need to feel comfortable and master the material. This is all on the test on Monday. So make sure that you're, keeping up with things. There is a My Math Lab on 2.4b as well. Now, are there any questions on the Desmos aspect that would allow you to check your work? Or are there any questions on the few examples that we just did? I'm happy to answer any questions now before you go off and try these piecewise functions on your own. No questions? Do we like these piecewise functions? No comment? No comment. That's sad.
They're good.
They're good. You like them. I'm glad. Thank you. I love them. Now they get very exciting. They get challenging. In some instances, you have to come up with the equations, right? And then once you have the equations, you have to put it together and answer the question. So they get a little challenging, but notice in some instances, I gave you the piecewise function. I asked you to evaluate it for different inputs. So you have to figure out which rule you're using in the piecewise function. In other instances, you're given the piecewise function and you have to graph it. And then you have to state the domain and range. In other instances, you're given the rule and you have to evaluate it for different inputs. That's what you're doing there. Now these, you've been given the graphs, and again, you have to determine what the output is. And then from here on, you're looking at the graph. You've been given some components of the piecewise function, but you have to figure out either the interval or the rule corresponding to an interval given the graph. So there's a lot going on here. You have a lot of opportunities to become one with piecewise functions. So you have your work cut out for you in tomorrow's class. I would like you to have attempted, each type of problem here so that we can, ask questions and answer questions so that we're prepared for the test on Monday. No questions. Okay, we did it. Whirlwind, 30 minutes, introduction to piecewise functions. Have a wonderful rest of your day, and I will see you tomorrow.
Thank you.
Bye,
Bye.
Dr. P.
Bye.
Thank
Have a good
you.
day.
You're welcome.
Thank you.
Have a good day. You have lots of math to do. Bye.